Conceptual schema diagram, I've just put various letters all over it, so you don't necessarily need to know that this is a student code or a address or a phone number or a postcode or any of that stuff to work out what your tables are. We always start, we start with ternaries. Okay, so if you go and find your ternary one, in this one there's actually two of them. So the first ternary we might pick off is this one here that's got J and A as the combined thing. Okay, what hangs off J and A, Ben?
What hangs off J and A? G and C.
Okay, so this whole thing here is 1. Okay, so there's 1. We write it down. G, A, C and G. Okay, we then need to identify what our primary keys are. What are they, AJ?
J and A.
Okay, so our J at the front here and the A there. Because they're either side of, they're the sort of the joined pair in the ternary, they'll be your primary key. So that'll be something like student code, subject code, those type of things. There's another ternary there as well right beside it, so A and F. What hangs off A and F, George? Don't rush me, George. Would it be K and B, perhaps? Oops, hang on, I've got to go up here to get that one as well. So we got A, F, K and B. Okay, so there's our two ternaries picked off. Now we just look at all the binary ones. So if we look at B and H, this is a very simple one. They'll be in a table together. We all happy with that? Okay. Which one is more important, the B or the H? Why? It's closer. Closer to what? No, not necessarily. Okay, why is B the preferred primary key over H?
Because it's 1 to H.
Okay, we look at this thing here. So that uniqueness constraint is very important. If we want to pretend it's got a little arrow on it like that, it's saying B is more important than H, so that is why it becomes our primary key. Okay, looking at this part here, I made this a little bit tricky in that we've got one going one way and one going the other way. What does that mean in the whole scheme of things, Callum?
It means that D is going to be the primary key of a table with F.
Okay, so D and F are going to be a table together. F and L are going to be a table together. If I had that line there, D, L and F would have all been in a table together. But because it's saying D is more important than F, that means it's in the table with it. So we've got one here, that's F and L. And the most important one there is obviously the F one, because it's got the little arrow pointing to it saying this thing here is more important than the other one. The other one here, D and F. D and F. D is more important because of that thing. Again, this little thing is saying I am more important. So D is the main one. F just hangs from it. Okay. You usually get in the habit of putting your primary keys at the front. You don't have to. There's nothing wrong with doing it other ways. Okay. That leaves us with this stuff here, K, E and I. Okay, which one is the most important of those three? E, why is that, Hamish? Okay, so if we look at E, it's got two little things aiming towards the middle of it. So E, in this particular case, is very important, leaving I. Again, if these were at different placed, it would be a completely different setup, and that's why we do this. Yeah.
Why table 2 where it says A, E, K, B? Why is it A, E, K, B?
That's F.
Oh, is it?
That's an F. Yeah.
Oh.
Yeah. So that thing's an F. Looks like an E when I underlined it. Okay. Getting that stuff right is really important. So that's why we do uniqueness constraints. It's not just so you remember have only one. It's so we actually have those ones there. Once you get that done, you've got your tables worked out. You've got your primary keys worked out. And now we're at the stage of going to access and creating our tables. Okay, so it's a sort of a longish process to get there, but if you do it properly, remember it's called normalisation, just a big fancy word for design this database effectively. Righto, that'll do us.